In this video, we will solve a question on output elasticities with respect to capital and labor. The question is, consider the production function, that is Q, which is output, which is a function of capital and labor, which is equal to 2 under root K plus 3 under root L whole square. If n subscript K and n subscript L denote output elasticities with respect to capital and labor, then find the sum of output elasticity of capital and output elasticity of labor. Options are 2, 1.5 and 4. Okay, so how do we solve this question? So we need to find out nk and nl. Now let us first find out the nk, that is output elasticity of capital. That will be equal to the change in the output due to the change in the units of capital employed times K divided by the output. Okay, this will be an output elasticity of capital. Likewise, n subscript L means the change in the output due to the change in the units of labor employed into L upon Q. Then we need to find out the n subscript K plus n subscript L, that is the sum of these output elasticity of labor and capital. Okay, so how do we find it? Let us see here. So first we need to find out this term dq upon dk. So we have this production function, that is Q is equal to twice, in place of K, can I write it K raised power 1 upon 2, plus then we have thrice L raised power 1 upon 2 whole square. Okay, so first we need to find out this dq upon dk, that is the partial derivative of production function with respect to capital. Okay, if I partially differentiate it with respect to K, first we apply the power function rule, exponent becomes coefficient, so this 2 comes here. Then we have twice K raised power 1 upon 2 plus 3 L raised power 1 upon 2, and exponent is subtracted by 1, so it becomes 2 minus 1, which is 1. We don't write it. Times we apply the chain rule, the derivative of this 2 K raised power 1 upon 2. Here we have to apply, because we apply power function rule, then we need to internally differentiate with respect to K. Okay, now we have 2 K raised power 1 upon 2, so first we have 2, the derivative of K raised power 1 upon 2 will be, so again 1 upon 2 becomes coefficient, so we have 1 upon 2, and exponent of K is subtracted by 1, so it becomes 1 upon 2 minus 1 is negative 1 upon 2. Okay, and this is our dq upon dk. So here what happens, this 2 and 2 gets cancelled, so dq upon dk is this term, and to this we multiply K upon Q. So let me write it here now. So here we have, so we got dq upon dk came out to be twice 2k, or let me write it here to make sense. Now dq upon dk, del q upon del k into K upon Q will be equal to, so del q upon del k is this term, that is 2 times twice K raised power 1 upon 2 plus thrice L raised power 1 upon 2 times K raised power negative 1 upon 2. So this is this derivative times this term, that is K upon Q. So we have into K, and what is Q? Q is this term. Okay, we divided by this twice K raised power 1 upon 2 plus thrice L raised power 1 upon 2 whole square. Okay, so here you can see we have 2 terms here, one term will get cancelled with this, so we will be left with, and here K raised power minus 1 upon 2 times K, so we have the same exponent, so 1 upon 2 plus 1 becomes 1 upon 2. Okay, so we have K raised power negative 1 upon 2 times K raised power 1, it becomes K raised power negative 1 upon 2 plus 1 because we have the same exponent, so we have same basis, we can add the exponents here. So we have k raised power, so it becomes negative 1 plus 2 divided by 2, which becomes k raised power 1 upon 2. Okay, so when we multiply these two, it becomes k raised power 1 upon 2. And let me write it here. So we got twice. So this term vanishes, this gets cancelled, so we are left with twice k raised power 1 upon 2 divided by one term we are left with here, k raised power 1 upon 2 plus 3 l raised power 1 upon 2 whole square. Okay, this is this n subscript k, that is output elasticity with respect to capital. Okay, so let me write it here. So n subscript k came out to be do I have the space? Oh, okay, so n subscript k came out to be twice k raised power 1 upon 2 divided by, okay, I have the space, so twice k raised power 1 upon 2 plus thrice l raised power 1 upon 2 whole square. Okay, so this is n subscript k. So this term, to this we need to add n subscript l, and we need to find out that very thing. For that, let me rub this out again. Now this time we differentiate dq upon dl with respect to l, this partially. So dq upon dl, dq upon dl will be the partial derivative of this function with respect to l. So again exponent becomes coefficient first, so we have then twice k raised power 1 upon 2 plus thrice l raised power 1 upon 2, and exponent is subtracted by 1. Then we multiply it with the partial derivative which is in the parenthesis with respect to labor. Okay, this time again we have first 3, exponent becomes coefficient, we have 1 upon 2, and exponent is subtracted by 1, it becomes negative 1 upon 2. So this is our dq upon dl. But we are supposed to find out dq upon dl into l upon q. Okay, so this is dq upon dl, this term. To this we multiply by l upon q. So we have into l upon q is this term again. So we have divided by twice k raised power 1 upon 2 plus thrice l raised power 1 upon 2 whole square. Okay. So here one term will get cancelled. We will be left with, so that is dq upon dl l upon q. It comes out to be here this 2 and this 2 gets cancelled. So we are left with 3 times again we have the same basis, we can add up the exponents, it becomes l raised power 1 upon 2, and we have this term in the denominator, that is twice k raised power 1 upon 2 plus thrice l raised power 1 upon 2 whole square. Okay, this is our n subscript l. Now since we need to add this, so n subscript k is this term, n subscript l is this term, so we have thrice l raised power 1 upon 2 divided by twice k raised power 1 upon 2 plus thrice l raised power 1 upon 2 whole square. Here you can see we have the same denominator, then we can add up the numerators. So we have twice k raised power 1 upon 2 plus thrice l raised power 1 upon 2, and in the we don't have the square here, because one term gets cancelled. So in the denominator we have twice k raised power 1 upon 2 plus 3 l raised power 1 upon 2. Okay, so here you can see the sum of output elasticity with respect to capital and labor will be equal to, so this term gets cancelled with this term, so we are left with 1. So the output elasticity with respect to capital and labor, when we add them, comes out to be 1 in this case. I hope I make myself clear and you find out this video helpful. Thank you.